All right, and we are live. Uh, Welcome everyone to today's webinar. We're going to give it just a few minutes so folks can make their way in. But if you're joining us, hope you are having a great Wednesday. I'm Cortez. Welcome. Thanks for being here. Hope your Wednesday is going well.
Wednesday is off to a great start. Super excited and looking forward to a great conversation.
Excellent. If you're just making your way into the webinar, we're going to give it another minute or so for folks to make their way in. We have tax day coming up, so that is something on the radar. Not SBOM related, although I guess if you wanted to stretch yourself, you could say that there are government regulations impacting both areas. Yeah, we're just going to give it another few seconds for everyone to make their way in, and then we will officially get started. So thank you once again if you're joining us. Yeah, I think we can now get rolling. Hello, welcome, happy Wednesday. We're really excited that you've joined us for this webinar on addressing common SBOM challenges with Cortez Frazier, Principal Product Manager here at FOSSA. My name is Andy Drukarev, also from FOSSA, and I'll be your host for today's discussion. Before I go over our agenda and introduce Cortez, I'd like to cover a few housekeeping points. First, we'll try to answer any audience questions as they're submitted, but if we can't get to them, we'll also have time at the end for a Q&A. So we do encourage you to please post any questions you have in the questions section of your BrightTalk console. Next, this webinar is being recorded, and that on-demand link will be sent out to you after the event. And finally, we at FOSSA will also be following up with you after the webinar with a few additional resources and to see if there's anything we can do to help your organization with. Now, let's take a quick look at our agenda. The first part of the webinar will be a bit of a refresher for some folks on the call. For others, it might be some new information, but we'll cover some of the kind of SBOM 101 type material. So, kind of the who, the what of SBOMs, and then a look at some of the regulatory requirements that mandate SBOMs and the structure and the formats, things like Cyclone DX, SPDX. Then we'll briefly cover VEX, vulnerability, exploitability exchange, how it's related to SBOMs, and how it's used in vulnerability management. From there, we'll transition to sort of the meat of our presentation, which will discuss some of the common challenges that we see in a number of SBOM programs and strategies to overcome them. Then we'll kind of conclude with a look at a potential SBOM lifecycle management workflow that we think can also help address these barriers. So now, before I hand things over to Cortez, just wanted to quickly give a few words for folks who are not familiar with FOSSA. So there are two main parts of our platform. One includes solutions for managing risk in your open source software. So this would include things like remediating, prioritizing open source vulnerabilities, and identifying and complying with open source licenses. The second part, which is obviously going to be a focus of today's webinar, is SBOM management. And so, we have support for generating SBOMs, ingesting SBOMs, analyzing SBOMs, and using that to inform vulnerability management initiatives, and then securely distributing them. So now I'm very excited to introduce our featured speaker, Cortez Frazier. Like I mentioned, Cortez is a principal product manager here at FOSSA, and he's been instrumental in building out our SBOM functionality and working closely with a range of customers who use it. So he has a very informed perspective on this topic. So with that, Cortez, I'll hand things over to you to share a little bit more about your background and your current projects.
Perfect. Thank you for that wonderful introduction. As Andy mentioned, my name is Cortez. I'm one of the product leads here at FOSSA. We're really excited to talk to you all about both the challenges with SBOMs and then some solutions that we kind of have in place around managing them. First and foremost, I have a little bit of background in, hey, why should you even listen to me? Why is that important? All that kind of good stuff. Prior to working here at FOSSA, I've spent a lot of time kind of operating as a practitioner itself. And so at Puppet, I was building a cloud security posture management product, which then relied on a lot of my security experience, which came from GE Power. At GE Power there, I was responsible for about 1,800 developers, 600 applications, huge coverage, only about 3 of us on the team. And so probably in similar experiences that either the legal or security professionals on this call today are kind of experiencing. Had a lot of experience actually implementing and scaling both SEA programs, but then also what would now become SBOM programs. At the time, we didn't call them SBOMs, we just called them bill of materials, but it was kind of the early entrance into getting that experience. And so having a lot of an opportunity to deal with some of the challenges for managing projects at scale, combining them into application level SBOMs, and then distributing those in a way that you can continuously monitor is kind of how I got my foot in the door in this space. And yeah, I'm really excited to talk to you a little bit about what you can expect from a software bill of materials perspective. So before I kind of go into a lot of the details on some of the challenges that you want to be mindful of as you think about building and scaling your own software bill of material programs. Let's kind of set the stage just a little bit on what SBOMs are, who should care about them, how they're being used, and things of that nature. Looking at the audience, I can tell a lot of you have probably already heard a lot of this information before, so I'll go over it relatively quickly. But a lot of this kind of kicked off back in 2021. You can think about really large incidents like Equifax and then SolarWinds, and then also Log4j, and these being catalysts by which it became very clear that while we were getting a lot of benefits from open source, there were actually some potential negatives as well, in particular on how transparent products are being with the software components that they're using, and thus the impact of these 0-day vulnerabilities or critical vulnerabilities as they come out. And so Executive Order 14028 came out and wanted to kind of start the conversation around how do we think about managing these components, and how do we think about giving insight and transparency into consumers of software applications to be able to have more information to be able to react much faster when these type of events occur. That said, who should really care about these things? There's really kind of 3 personas, if you will. If you're producing software in any way, shape, or form, in particular, if you are then being regulated by some of these regulations I will go over here in a bit, you absolutely need to care about them because your customers are going to ask for them, and you'll need to be able to produce them. As a purchaser of software, this is actually probably the most interesting use case in my personal opinion, which is then actually demanding these SBOMs from either your suppliers, vendors, or anyone that you're doing business with, so that way you can then have that end-to-end insight from first party to third party across your entire supply chain there. And then lastly, operators. This is more of an internal use case of being able to say, hey, you have, likely massive organizations, even in smaller organizations, desperate parts, different profit and loss centers or departments that are all generating different products. And so how do you then start to have that single pane of glass where when a new 0-day vulnerability comes into place, or if somebody changes their license or some of these other really critical impacts, you can then quickly scan across your entire organization and understand where you need to start making changes. And so those are kind of our 3 personas, if you will, that need to be considering and thinking about SBOMs. Why? You can think about a bill of materials very similar to how nutrition labels are approached, which is help me understand what's inside of this software application, what its impact of those individual ingredients are, which will manifest in the form of VEX statements and other similar attestations. And then lastly, how do I be able to have the context so that way I know where these particular components are coming from, combine those in those application level SBOMs to then figure out where the source is, to then be able to address any issues that begin to kind of pop up because of that. So that is kind of, kind of an introduction on who, why, and what SBOMs are, who should kind of care about them. There's also some kind of additional information that's been coming out a lot, which is additional regulations that are provided orders of magnitude more clarity on what you actually need to do with these SBOMs, what are some minimum elements that need to be associated with them, and then specifically what industries are going to be covered under them. I do want to spend a little bit of time here because I think this is actually where a lot of the nitty gritty, if you will, comes from. already kind of talked about the initial executive order. In order to comply with that, the NTIA put out a set of minimum requirements, so that way you will know what information needs to be included in the software bill of materials to make it complete. These are things like unique identifiers, author, supplier, manufacturer, any known vulnerabilities associated with it, of course, component name, version, all those things, which we'll show here in a bit. From there, we start to get into some much more interesting regulations, I would say. PCI DSS 4.0, kind of around that March 22 timeframe, kind of put out their initial proposal that kind of goes into effect in the March 2025. As far as being a hard requirement, right now it's kind of just the best practice, and a lot of industries are preparing for generating and maintaining these SBOMs on a regular basis in order to comply. Now, very transparently, it does not call out an SBOM by name specifically. Rather, it uses this very verbose inventory of bespoke custom software. There's lots of ways potentially that you could go about obtaining that inventory, but from my perspective, this has been the perfect tee up for what will then become a software bill of materials. And so if you are handling any kind of customer, credit card data information, banking information, things of that nature, you likely will be subjected to this requirement, and something that you should absolutely have on your radar. There's both that initial production of the SBOM, but then more importantly, the continuous monitoring. And this becomes very, very critical if you're actually receiving any software or hardware from a supplier. And so if you, are receiving some type of payment processing machine that you then sell underneath your own brand, you actually then need to obtain a software bill of materials from your suppliers, combine that together with the additional software that you've added on top to then monitor this completed release on an ongoing basis to make sure that it is cyber secure. From there, we start to get into two more really interesting regulations. First, the EU proposed the Cyber Resilience Act, which has a whole host of requirements around any of these, kind of digital assets, if you will. I think they call them products with digital elements is the specific terminology. And so this is essentially any internet connected device, anything that, whether that is externally facing or internally facing. This is also regulates anyone who does business in the EU. And so even if you're not originally a vendor founded in the EU or operating in that regard, if you deliver any end products. And so this covers anything like laptops, smartphones, any smart connected devices, firmware and software, automotives with displays and all the fancy GPS navigating that we all take advantage of today. So this requirement is actually fairly comprehensive, and I would imagine just about any modern business, unless they are purely a hardware manufacturer, is going to be subject to needing to deal with this. I think the SaaS requirement is also really interesting for the CRA, specifically if you do any form of data processing as a part of your SaaS application, you are also now in scope or considered one of these products with digital elements. And so if you have a smart thermostat that you control with a mobile device that allows for you to then make decisions and choices about that, you are within scope. If you are a industrial manufacturer, that it gives your customers ability to be able to tweak and fine tune the turbine speed, for example, that's coming from my GE days, is something we would do on a regular basis. You're also now in scope for this regulation. And so that was originally proposed September 22, and then actually just this past March has been approved. It is pending to go into effect sometime in April, or to be fully ratified sometime in April. And then from there, we'll get some additional information. Whole host of requirements out there that need to be met. And actually really excited for this because I think it's going to push the whole industry forward. The last one that I wanted to spend a little bit of time on in the short term is going to be around FDA, specifically for the medical devices mandate. This is allowing for anyone who has to do any type of like 510K submission, the PMAs, and all these different forms of medical device regulations that need to be met. You have to both produce your software bill of materials. That is, once again, that combined application level, or whatever your delivered product is. If you have a dialysis machine, MRI machine, any of these type of devices, but then also the continuous monitoring requirement to make sure that you're both validating any new vulnerabilities that come up and then be able to disclose those to customers. And I'll talk a little bit about the disclosure, both from a distribution and a VEX statement or standpoint here in a bit. But that is the kind of high level of a lot of recent regulations that are starting to make this a requirement. I think the CRA in general is going to have likely just about every listener on this call impacted by this, which is great. That said, what is a SBOM, if you will? And let's look at a couple of examples of that. Two very popular SBOM formats that have kind of bubbled up to the top today: SPDX and Cyclone DX. You've likely heard of both of these at some point in time. They each have different roots, if you will, but are attempting to solve the same problem. SPDX coming out of the Linux Foundation, Cyclone DX coming from OWASP. That does naturally have some implications from the lens of SPDX originally maybe being a little bit more license focused, Cyclone DX originally maybe being more vulnerability focused. But I think both of these standards have matured to the point they serve both use cases extremely well, and it's purely a preference on what tooling you're using, what type of SBOMs are you receiving from your suppliers and vendors, and then how you want to go about processing and analyzing that information. They're always going to want to first address the actual project or application itself and be able to give some high-level metadata associated with that. Who created this SBOM? When was it created? Who's the original author or manufacturer for this? And then from there, we'll break out into each individual component. Each of these individual components will then also have an array that associates all the relevant metadata. You can think of that like things like what licenses are associated there, what evidence of those licenses in the form of file matches, what relationships exist there as it pertains to how many dependencies are dependent upon that either top level or direct dependency, and then be able to kind of walk that tree. So all in all, the goal is to make these as machine readable as possible. So that way, any tooling that you're using, whether that be FOSSA, open source tooling, or any other commercial tooling out there, can then process this and start to do that on a standard basis. For those who have never even seen a software bill of materials, here is essentially what you're looking at. Both these are in JSON format, just for the ease of understanding. SPDX supports JSON, XML, tag value, and maybe a few others. Cyclone DX primarily in JSON and in XML. A lot of the industry is centralized around JSON just because of that ease of consumption. But what you're looking at here is that top level metadata saying for this particular kind of component, this is component metadata. For this particular component, what information is associated with it, right? Version, name, a unique identifier, which we'll spend a lot of time talking about because that is incredibly important. Here you can see in the BOM reference on the Cyclone DX one specifically, we call that a PURL, a package URL. It's kind of called out directly at the bottom as well. And that allows for both yourself as a, either SBOM producer or consumer, but then also any tooling you use to uniquely identify that component. And I'll speak to you in a bit on why that unique identification is so important. But this is SBOMs themselves, really quick introduction to be able to understand what they look like, where they come from, what were some of their original use intentions. So.
Nice. Thank you, Cortez, for that great overview. I think we have one question before we move forward, which is, how is hardware reported? What is the evaluation criteria and process?
Yeah, that's a great question. So from a hardware perspective, right, you have to think about separating the the bill of materials from the regulation, meaning that if you are doing, say, like a 510K submission, absolutely, you have to include the hardware that'll be included in that. There's a whole bunch of requirements that the FDA has there. But if it has any form of internet connection, has any software embedded on it, then you will be required to also produce a software bill of materials for that. And so there are some newer bill of materials standouts. Cyclone DX in particular supports the HBOM, the hardware bill of materials. And so you can actually then combine your hardware bill of materials with your software bill of materials to then have that completed submission if you're looking for do something for like the FDA specifically. I think on the CRA side, you have to track the hardware to be able to do that one-to-one mapping between what software needs to be included, but it only matters if you're one of these digital devices. And so if you don't have any form of internet connectivity or on device processing, then it's not something that you have to be concerned about. So the TLDR there is listing the hardware that is included is the most basic requirement, and then you can combine that with your software bill of materials to have that completed submission.
Great. Another comment, which is not a question, but just somebody who said great intro. So thank you once again. I
Absolutely.
think now, before we sort of dive into the really kind of the nitty gritty of the challenges that we see, especially perhaps early stage SBOM programs, or really all SBOM programs encounter, wanted to spend a minute talking about VEX, vulnerability exploitability exchange, because I know this is something that an increasing number of organizations are paying attention to and thinking about trying to adopt. And it also impacts very directly one of the challenges we'll cover, which is this concept of continuously monitoring vulnerabilities. So, Cortez, wondering if you could just kind of give us a brief intro on VEX, what it is, how it's used, what the formats are, so on and so forth.
Absolutely. And I'll take a slight step back, and I want to kind of bring up what I think to be three kind of core use cases for software bill of materials. The first one is simply enumerating the components that are being used in a bill of materials, right? And so essentially a list that could be a CSV file, right? But so I think the formats themselves become less important in that regard. The formats themselves become much more important in the second two use cases. One of them, which is actually becoming a newer use case, which is just another form of license attribution. Because you can include the full license text and copyrights in both these specs, whether that be in plain text or encoded, then you actually can meet attribution requirements with the software bill of materials as well, allowing for you to have one document to kind of match them all. Of course, make sure you include your intricacies of including all the different copyrights, notice files, full license text, all of which is fully supported in most licensed devices. But then lastly, what I find to be one of the most interesting use cases is then vulnerability reporting. As we all know, the software bill of materials itself tends to be very static, but the information around it can be very dynamic, meaning that the moment that you produce a bill of materials, in particular if you're including any vulnerabilities there, that is immediately obsolete because there could be a new vulnerability that comes out the next day, right? As we saw with XEUtils just recently. And so what transpired is then two solutions to the fact that this vulnerability environment is so dynamic. One is enumerating the vulnerabilities themselves, which is your vulnerability statement, and then two, analyzing the exploitability or what the actual impact of that vulnerability is, which is ultimately what birthed the VEX, the vulnerability exploitability exchange. And so, as anyone who has spent any amount of time doing any form of vulnerability remediation or vulnerability management program, you know that CVEs in and of themselves can be very noisy. I absolutely appreciate MVD, MITRE, and all these other data sources that we leverage to actually be able to understand what potential CVEs are, but that is in and of itself. These are only potential vulnerabilities. These are not confirmed or acknowledged vulnerabilities. And so only the hardware, software, or vendor themselves can actually give the necessary insight to be able to speak to if a particular vulnerability is either reachable, truly impactful, if that bit of code is actually being deployed along with the final production version, or is that just like a test or compile dependency? There's so many reasons why a particular vulnerability may not be exploited. I was looking at a CVE recently. I don't remember the one off the top of my head, but I do remember that the only way for it to be exploited is if you included a line of string that had more than 254 characters or something ridiculous like that, right? And so, yes, that CVE exists, but only underneath these specific circumstances. And so, in order to address this communication problem, and in particular to allow for anyone consuming an SBOM to have the true context of their vulnerability posture, this VEX statement is absolutely critical. And so what this does is then take for each individual CVE that is enumerated, whether that's embedded directly in your software bill of materials or hosted separately, for each CVE, giving you an opportunity to annotate whether that particular vulnerability is affected or not affected. And if it is not affected, why? What is your justification for that? What is your reasoning? And do you have any plans to remediate that if not? And so there are a whole host of VEX formats, if you will, those kind of coming from CycloneDX themselves, OpenVEX, and then CSAF as well. And within these existing formats, there are some slight differences in the justifications in particular. We and most of the industry have chosen to centralize around the CISA justifications rather than the ones that are like Cyclone DX specific, but OpenVex and CISA have their own iterations of that. Some of the things that you want to include that are absolutely important, the product details is massive. And so whether that is a CP or Perl, my preference will be Perl when possible, but obviously for like commercial software and some of these things that are not open source available, an accurate Perl is not going to be possible. And so you will have to include a CP there, the vulnerability details, but then most importantly, the actual analysis information, which analysis information includes the status, whether it's affected or not infected. It also could be under investigation, fixed, remediated, some of these other statuses, but then also that VEX-based justification. So things like inline mitigation exists, the component's not distributed, the actual code is not reachable. These are all VEX-based justifications that you want to make sure that your developer, whoever's actually working on these individual software components, is actually enumerating that you can then communicate to your customers on an ongoing basis or whoever's consuming this software. Let's get a little bit more tactical here, right? I think talking about VEX in a theoretical standpoint is nice. Being able to actually see what one looks like and what it means is a lot better. And so looking at my screenshot here, you can see for this CVE 2024-2236, it has a medium severity, CVS score of 5.9. In this case, we have not actually analyzed this particular vulnerability. This is considered an active vulnerability in FOSSA terminology. You can, insert whatever tooling that you desire. But the most important part is at that bottom left, which is the analysis here, states that it is affected, and thus there's no additional information needed or required. And so anyone who would consume this particular software bill of materials would view this as an active vulnerability and one that they may need to put their own mitigation techniques in place. And I would then transition to imagine a scenario where actually this vulnerability has come out. We've then, chucked this vulnerability over to our development teams to help us understand, hey, are we actually impacted by this? And if not, can you give some information on the why? And so at this point in time, a developer has now actually analyzed this particular vulnerability. They've determined, no, we already have inline mitigation in place for this. That way it's not going to be in our production and deployment. And then you can actually include, more details if you would like, whether that be in the form of a Jira ticket, a Google Doc, or whatever form of messaging that you desire. And so at the end of the day, you can think of your VEX statement as the additional context, the additional either developer or business context that anyone who's consuming an SBOM will never have, and thus you have to provide for them. Else, when they ingest those software bill of materials into like a tool like FOSSA or any other SBOM import tool, they will see a bunch of vulnerabilities that they are likely not impacted by until they are able to view that VEX statement.
Thanks, Cortez. One quick question before we get into our next section,
Absolutely.
and that's what is your view related to bill of materials attestation?
Yeah, that's a really great question. I think bill of material attestation is necessary, right? Because at the end of the day, like it is just a JSON file. It'd be very, very easy for me to edit that JSON file in some way, shape, or form, and then the version of it that you're receiving is not actually accurate. And so I do think some form of attestation is necessary. There are some, more basic, easy forms, like just kind of taking a hash and being able to provide that from a checksum perspective, and then allow for your users to compare to that. There are much more complex forms in the form of using, open source tooling like SigStore to then be able to associate a private key with the particular version to make sure that it's not annotated. And then we even have, some partner forms in the form of, you can think of tools like DigiCert, which could then actually attest to the I can't say that word today, but authenticity of I give up. But the auth word of that particular file. And so I do think it is a necessary evolution as bill of materials become more mature, but it is likely early stages from what I can see from the market. I think at minimum, though, getting some form of hash or checksum is what I'd be looking for out of a file.
Cool. So now, we're going to transition to talking about these challenges that if you're in the weeds or, working closely with your SBOM program, you probably know all too well. If you're in the early stages or kind of more involved from afar. You might not know now, but you probably will get to know before too long. And we're going to focus on three of these, but kind of within these three buckets, there are a few different, I think, specifics that we'll cover. So Cortez, we'll turn it back over to you to kick us off with our first challenge around data normalization and standardization.
Absolutely. And this is one of the most interesting challenges, I would say, because you as a user, whether that being producer or consuming SBOMs, actually don't really have a ton of control over this particular challenge. And you're going to be heavily reliant on either your open source tooling or commercial tooling. And I would spend a lot of time having real deep conversations with them on how they're interpreting SBOM specifications. So one of the big issues or challenges, if you will, with software bill of materials is the spec itself is standardized, right? CycloneDX, SPDX, you need to have author, you need to have supplier, you need to have manufacturer, right? Originator, all this information is standardized, but the inputs to that information is not in any way, shape, or form. And one of the most common ones that I see that I run into from a challenge perspective is when you think about the difference in supplier, originator, and author, right? And so if you think about the intention of these particular fields, a supplier is the person actually distributing a particular component to you. A author, I think very clearly, is someone who is authored that particular component. And then originator could be a person or organization who has originally published or created that particular component. But that becomes really, really complex in the world of package managers, for example, right? And so if I were to take React as like a really, really good example, React is distributed via npm, and so from my perspective, npm is actually the supplier of that particular component. However, some other tooling interprets the supplier, in this case, as Meta. Now, I would heavily argue that Meta is the originator of that particular component, and then the author is going to be the individual developers who have actually contributed and worked on that particular one. And so that normalization challenge means that it's very easy for tooling to kind of check the block, if you will, and say like, yes, of course, we include supplier, we include author, you're NTIA compliant, but actually you're not, because the way that they've interpreted those particular fields is false. And I do think that's one that we as an industry are going to have to coalesce around and come together to standardize, and is, in my opinion, one of the biggest challenges. Now, another one that's worth calling out, and anyone who has attended any webinar that I've spoken on previously probably has an understanding of my strong feelings around CPE. I think CPE is a fantastic attempt at uniquely identifying components. I think that it has a lot of challenges. You've even probably seen recently in the news that the MVD and MITRE have actually stopped generating CPEs for any new vulnerabilities coming out, and that makes it difficult to then uniquely identify them. Now, from my perspective, it's a little bit of a non-factor, because I think CPE was a terrible means to go about uniquely identifying components in the first place. And the reason being is on the right-hand side of my screen here. If you think about what a CPE is, right, common product enumeration, it is attempting to provide a standardized means for both commercial and open source tooling to be uniquely identified. However, a CPE is only created when a vulnerability exists for that particular version of that distribution. Now, that would be fine if we were, all creating CPEs in the exact same way, or if we could anticipate how, some of these organizations like MVD and MITRE are going to create CPEs. But oftentimes it is really, really small differences, right? As you can see, all four of these CPEs pertain to the exact same software component in version, but actually have different enumeration each time. And that is not a problem if you correct the right, or if you guess the right one. It is a massive problem if, a vulnerability has not been created for a particular component yet, whether that is your commercial tooling or open source tooling, then has to generate a CPE for you that you then do a lookup in the MVD database on, and you will probably find 0 vulnerabilities. But your first interpretation of that will be, oh, wonderful, right? I'm not affected by any vulnerabilities. But the reality is the generated CPE may not be a one-to-one match to the version of it that MVD or MITRE creates whenever a new vulnerability actually does exist for that CVE. And so that is the danger loop, if you will, that will allow for you to have a false sense of security as it pertains to unique identifiers. And so I'll stop talking about this one enough, but I think the most important piece to kind of take away from here is that a SBOM, a software bill of materials, is only as accurate as the data that is output within it. And without having really strong conversations and really good understanding of what the intent of each field is, then you may actually be producing software bill of materials with false information inside of them. Now that we've kind of gotten out of, one of the challenges that I think is not really much in your control and a difficult one to manage, let's start talking about a few challenges I think you have firm control over, and ones that you should be actively thinking about as you kind of build and scale your software bill of materials programs. One of the big ones is thinking about vulnerability management. I kind of alluded to this earlier, but the software bill of materials itself is static and the information that goes in it, right, unless you edit it or need to make a change for whatever reason, but the analysis around that information is dynamic. That is not just vulnerability management, although that is a huge one. And there's also things like end of life support, which end of life support is a firm requirement for the FDA in particular. And then a lot of other regulations are starting to consider that, right? Is it actively maintained? We have a concept internally called abandonware, which is a component that has not been maintained or updated by the maintainer over the course of the last 2 years, thus is effectively considered end of life. And so how do you think about that? How do you manage that? And how do you make sure that any software bill of materials that you're either consuming or producing will continuously be updated from a dynamic perspective? There's one more challenge as well in this category, but I'll speak to that one here in a second. And I think the best way to kind of go about approaching the vulnerability management challenge is one to start with a true unique identifier. And there's essentially two approaches that you can take whenever you're consuming a software bill of materials that you want to continuously monitor. One is a Perl focused approach. And so going back to Perl, that is a package URL. That is a unique identifier that says for this particular component, for this version, coming from this particular namespace or package manager, that is fully uniquely identified. And that helps you in case someone forks a repository, does some type of code commit changes, and now that may or may not have the same vulnerability exposures. Now, using Perls, you can actually then ingest your software bill of material. You can, use open source tooling like Perl Parser to deconstruct that component, where you can ingest it in a tool like FOSSA, and then from there compare those Perls to a database of vulnerabilities, right? That could be looking them up manually. That could be OSV, GitHub Advisory. Hopefully you're using some tooling to kind of address that. And this is a really interesting approach because as new vulnerabilities appear, because they will always be associated with that Perl, you'll actually have an up-to-date understanding of what your vulnerability risk posture is. Now, the kind of second piece there, right? If we think back to the earlier conversation, Vex is incredibly powerful. And so why, sift through, hundreds of CVEs that you may not actually be impacted by when a supplier is actually providing you the additional context that you need in the form of a Vex statement. And so having those, statuses, the justification, the response, are they actually going to fix it? Do they have plans to fix it in the next quarter or in the next year? All that kind of information is useful. But the one kind of call out that I think is important to consider when you think about a Vex focused approach, which is that is the supplier's determination of a vulnerability, right? And I think in particular, when you think about these status justifications, you have to take your own internal risk tolerance into account to have a true sense on if you're affected by that vulnerability or not. And so I think inline mitigation already exists as one of the most interesting ones to me, because if I am a super critical infrastructure organization that I am responsible for 30% of the world's power, it's a GE shout out by the way, then I probably will have a higher risk tolerance than a organization that is creating donuts, right? I love donuts. But the risk tolerance there is just significantly lower in comparison. And so our donut shop manufacturer with this really cool application for ordering and delivering donuts may be very, very fine taking you at face value that, hey, inline mitigation exists, good, you got this vulnerability taken care of, I don't need to worry about it. If I am a critical infrastructure manufacturer, I actually may say, whoa, well, I don't know how accurate that inline mitigation is. I don't know, because ultimately the vulnerability does exist. It is accessible. And if there is another means by which someone can, perform remote code execution or something of nature, compromise your system, then they may actually be able to work their way around that inline mitigation, or I may view that inline mitigation as not sufficient. And so I think taking that Vex focused approach is a great initial input to help you cut down on noise so you can figure out which particular vulnerabilities that you should be focused on or worried about trying to address most immediately. But I would caution from using that solely as a source of truth without taking those particular statuses in context of whatever your own internal or organizational risk posture is. So just one of the big takeaways that I would want to make sure everyone keeps in the back of their mind as they start to receive these VEX statements, CSAF, open VEX, whatever the format is, from their particular suppliers and vendors. Awesome. Lastly, I'm going to get into the last challenge, but this is a newer one. But at the end of the day, a software bill of materials doesn't do anyone any good if it is sitting in a Google Drive somewhere or sitting in an email document, right? And so how do we then distribute these SBOMs on a regular basis? And how do we make sure that they're up to date as new vulnerabilities appear? This is super important if you're embedding your VEX statement directly in the SBOM itself. Slightly less important if you're hosting the VEX statement separately. But even then, you'll then need to distribute that VEX statement and keep those up to date on a recurring basis as well. And so we've started to think about distribution, right? There's some kind of early distribution methods. Email and Google Drive is honestly how most people are distributing SBOMs today, which as a product manager absolutely grinds my gears, but I understand that we got to crawl before we can walk and run and all those kind of good things. But of course, as I mentioned, it is immediately out of date. And so being able to either host that VEX statement separately and be able to continuously update that is a critical component to having a high quality software bill of material lifecycle management program. But even if you embed it, having the ability to quickly publish and repost anytime new vulnerabilities come out, your developers have now done an analysis of that and then communicate that down to your customers. Another big challenge, though, that starts to come up as you think about distributing SBOMs is who should have access to it, right? Internally, I think we've long solved this problem with role-based access controls, make this very, very easy. Whether that is a developer who handles end-to-end from vulnerability remediation to actually publishing the SBOM itself, or for those of you who have like separation of duty requirements that you have to meet, having a CI engineer be responsible for publishing, having your underlying individual engineers responsible for actually analyzing and remediating vulnerabilities, so there's no conflict of interest there. However, I think the external piece is where things become very, very interesting depending on what your product is, what your concerns are from a data perspective. But that is whether you should be publicly sharing software bill of materials or doing that privately via things like time-based access controls or, in the future, things like integrating directly with federated IDPs. Now, I do think that there are orders of magnitudes to the amount of information that you're willing to share, depending on what your product is. I would argue very, very heavily that there is very few products in the world where publishing a software bill of materials publicly itself that only includes components, component name, version, and pearls is dangerous. And I will stand on that statement, and I'm willing to have as many debates with any security professionals as they would like on that particular topic. But I think that is an overblown concern, but one that I do completely understand, depending on what your industry is. That said, you can always publish that more scaled down SBOM publicly, and then either in an internal portal or with specific customers and suppliers who have a certain level of information that they require, then you can do these private sharings. And so we really like the time-based access token, so that way you can have granular controls on how long someone has access to that, and should that be on access on an individual level or on an organization level. And this becomes absolutely critical when it comes to addressing that second challenge, which is I want to share this with my particular suppliers. A new vulnerability comes out. I want to update them with the status of that, so that way they can spend less time, harassing me and building all these concerns around vulnerabilities that they're likely are not impacted by. They just haven't received that information from you yet. So as you think about some of the distribution challenges, that is just one of the big things that I would kind of keep in the back of your mind.
Yeah, no, that's a wonderful rundown, Cortez, of those three challenges. Before we get into the final part of our webinar, there's one more question I'd love to address, which is how can you be assured about the accuracy of the SBOM's declared components?
That is a great question, and I think the answer you may not like, which is you can't. right? I think it would be really, really difficult for me to say I have a commercial product. I'm providing a software bill of materials to you as a user, and you as the user, without having insight, having any insight whatsoever into that commercial product, that is a completely accurate SBOM, right? I think that you can put contract language in your contract agreement with those particular suppliers, and then you should always be then importing that, so that way you can actually track the changes of those SBOMs over time. And those are some additional methods to kind of go about validating that integrity. But ultimately, you do have to have a certain level of trust in your suppliers, or at minimum have consequences in place contractually if they are not providing you the information that you would expect or hoping for. So yeah, I know it's not the greatest answer, but I do think that a combination of contract language, and don't get me wrong, some of the regulations do have like some pretty strong, like I think the EU has like a 15 million fine, or 2.5% of the global turnover, if they are not actually complying with accurate SBOMs. And my understanding, I think they removed the language, but at one point in time, the CEO of your company actually had to sign each distributed SBOM for a particular release in order to attest to that integrity. And so I think most organizations probably have a tough time getting their CEO to sign every single release, but I do think that there should be some senior, either engineering manager or product manager within that organization, who should be speaking to the authenticity, finally got to say it, Andy, of that particular SBOM.
Nice. One more question to get to now, and then we have some others for a bit later. But it's, can you repeat your comment about broad public SBOM disclosure? So I think this is when you were talking about kind of what the real security risks are of publicizing an SBOM that has a certain level of information.
Yeah, and this very firmly kind of goes back to my experience, kind of being a security practitioner. Honestly, at D, we were very, very strict, and basically we would not share absolutely anything, right? Even internally, we were unwilling to share the composition of a particular application. My stance is very firmly that producing a publicly accessible software bill of material that only has component information in there. I think the vulnerability information is where risk can particularly be perceived. But if you're purely producing just a software bill of material that has a list of components and component versions used, it would be incredibly difficult for a bad actor to use that information in and of itself to then do something nefarious. And so I won't say there is zero risk. I do think the risk is so low that it is actually much more a net benefit for all of us to be producing these SBOMs publicly, unless you have some type of IP concerns, right? Because ultimately your IP is what is most important, and open source components being used inside of your application is not intellectual property from my perspective. So, but please, that is not a legal opinion. That is a Cortez opinion. So,
Yes. So the last part of our webinar, I think, Cortez, would love for you to sort of speak to our view here at FOSSA, your view of what sort of the ideal SBOM lifecycle management workflow looks like from the perspective of how it can address some of the challenges we've discussed. And I know that when we did introduce each challenge, you also provided some specific recommendations for addressing it. So I think, this last part of the webinar is more around like this high level kind of broader, tactics and strategies for kind of making all of these individual things come together into the bigger picture. And so wondering if you could, speak to that.
Yeah, absolutely. And so I think at the end of the day, when we think about the three challenges, right? So the first one being data normalization. I think I've kind of spoke heavily on that being a strong conversation that you need to have with your particular vendor, in this case, FOSSA, right? And I promise you, I'm more than happy to have whatever conversations with anyone on this call or future calls around how we think about the actual interpretation of each SBOM requirement. But I think the other two challenges are then immediately addressable with automation and tooling at scale. And so the way FOSSA thinks about approaching those challenges is by having automated generation of both your SBOM, but then also the VEX statement itself. Being able to import these SBOMs with unique identifiers or CPEs and associate vulnerabilities to them, and then also having some secure means by which to go ahead and distribute materials, whether that be public distribution or private distribution. And so looking at these challenges kind of one at a time here, One of the things from an SBOM annotation perspective, and this can, frankly, be done with any tooling of your choice, right? It's obviously going to be a very FOSSA kind of forward explanation, but any tooling that you're analyzing a project with, you should have some means to be able to add context to a particular vulnerability. In this case, we have a concept of ignoring vulnerabilities in FOSSA, and our ignore action has reasons associated with them. Every single reason is a one-to-one mapping with the NTIA compliant VEX statements. And so being able to have that specific justification and be compliant with the NTIA justifications, but most importantly, being able to add the reasoning. Eagle-eyed viewers may notice that this particular ignore reason is the exact same one that I showed in the VEX screenshot earlier, and being able to speak to how you're actually impacted by these. One thing that's really powerful about this workflow is obviously I'm showing you how you do this in the UI, but your developers can actually do this outside of FOSSA. They can do that via API or via Jira integration. And so they can actually annotate these ignored issues, never have to go into the FOSSA platform itself. And then the moment that you generate your new SBOM, whether you do that via the CLI or API or the UI, you will automatically pick up all of that developer's work. And so on a continuous basis, new vulnerabilities come out, your developer takes the time to analyze them, they analyze them, they post back to your particular ignored issue, why that particular issue is no longer affected, and then that clearly appearing in your VEX statement here, and that you can then generate, once again, a UI-focused approach, but this all can be done via API or CLI if needed as well. I think after you're, having that kind of continuous program where you're analyzing vulnerabilities and then attesting to, their status on a regular basis, you then have to then think about that second challenge, which is if I'm receiving any of these vulnerabilities from my suppliers, how do I then continuously monitor them? Because even if they embed that VEX statement in that SBOM, it's immediately obsolete. And so having those unique identifiers like Perl, being able to go into a tool like FOSSA or whatever tooling you desire, actually upload that particular SBOM. And it's very important that when you're doing SBOM uploads, that is not just storing that JSON file, right? I think that is, an approach that some people have taken. I think that is a, one step in a positive direction, but then being able to actually break these down into individual components, be able to pull out that Perl or CPE and then associate vulnerabilities based off of that component is what allows for that continuous monitoring on an ongoing basis. And that's actually the same thing that allows for you to meet a lot of these cybersecurity requirements that are coming out of the regulations, like the CRA in the EU, like the FDA, and like PCI. I think lastly then is now that I've, generated my SBOMs on a regular basis, I've annotated them with new vulnerabilities, I'm continuously monitoring any ones that I have to import and maybe even combine into a final application level SBOM. If I'm receiving that from a supplier, putting some secret sauce on top and then delivering that final file, I need to then distribute this to someone because just having that, sitting in my downloads file isn't going to do anyone any good. And so having a portal from both a public perspective and a private perspective, in full transparency, what I'm showing you here is currently in development here at FOSSA. We're looking forward to kind of doing an initial launch of this here in the next couple of weeks, and then a larger investments kind of throughout the rest of the year, and being able to say, hey, you can either publicly distribute this SBOM, or you can actually have private distribution managed by these time-based access tokens that I was mentioning before, so I can always continuously get new information on an ongoing basis. And so that is how we're thinking about addressing these challenges. I think there's lots of opportunities for this industry to get further in SBOM maturity as more organizations are both producing them and commanding them from your suppliers. And so if there's no other takeaway that you kind of take from this particular conversation, it is two things that I want you to massively keep in mind. One is making sure that you have accurate, unique identifiers, whether that be Perl or CPE, preferably Perl for any open source components. And then two, really start thinking about whether that's internal or external, requiring your suppliers or other P&Ls within your organization to start producing these software bill of materials so you can ingest them in some form of tooling and have that nice single pane of glass where you can quickly do things like a package search anytime the next, XE utils, log4j, Apache common text, even dependency confusion concerns with things like PyTorch, right? All of these things can finally be addressed if you have a single source by which to look across your entire organization. So with that, I'll kind of close out my kind of quick demo portion of it, but happy to answer any questions and look forward to being able to have more of these conversations with everyone.
Yeah, that was a wonderful presentation. Thank you so much, Cortez. If there are any questions that folks have, do feel free to submit them. We'll have a few more minutes. I'd say that also if you do want to see more about or learn more about sort of FOSSA's view of this world, feel free to reach out to us using the email addresses listed here. You can also just reply directly to the follow-up emails that we'll be sending. So we have a few more questions. They're both very much related to regulatory compliance,
Yep.
and I know some of them are in areas where we at FOSSA haven't necessarily covered as much, but I'll pose them, and these and we'll go from there.
Mhm,
So
mhm.
the first one is, what is your position related to the EU's Cyber Resiliency Act in relation to manufacturer responsibility related to upstream accountability?
No, that is a great question. So my understanding of the regulation is that the manufacturer is the one the formal person responsible for both generating the software bill of materials and making sure that vulnerabilities are remediated on an ongoing basis. Now, if somebody upstream is then, taking your particular manufacturer, device and then adding some form of secret sauce and then finally distributing that as a net new device, that then makes them the manufacturer, right? And so they are then responsible for any new vulnerabilities and remediation, but that will likely be dependent upon the software bill of materials that you're providing. And so it becomes this kind of daisy chained shared responsibility, if you will, very actually similarly to how open source license compliance is a shared responsibility between the author of a particular component and then anyone distributing commercial software, right? If you have that, GPL and you don't want to actually have to expose your source, but a particular author did not realize that they had that in their code, you are jointly responsible. And that is my same viewpoint on upstream accountability for any originally manufactured bill of materials.
Great. Next question. Do we need to provide an SBOM for software which is not supported anymore?
Yes, you do. Now that is regulation dependent, right? If you're thinking about like the FDA, for example, I think there's like a 10-year window by which that you have to maintain both the bill of materials and any kind of continuous vulnerability monitoring. Even if you don't plan to address any of those vulnerabilities, being able to capture that and then communicate that to your customers as a part of a back statement is a requirement. Now, if that particular software has been fully deemed end of life and you are no longer commercially responsible for that, then you do not need to provide that SBOM unless you have some form of commercial agreement with particular suppliers. And so, generally speaking, yes, you do want to make sure that you maintain that, but that is dependent upon your commercial relationship.
Great. Last question. And just if you could talk through, Cortez, what you're familiar with here. Just any thoughts on the proposed federal acquisition regulation, FAR changes? And there seems to be a misconception. It sounds like that an SBOM isn't required to be generated until you have an incident to report. So I believe this might stem from the activity in that 2021 Executive Order 14028,
Yep.
which does require people or entities selling into the federal government to produce an SBOM. And my guess here is that although I personally haven't seen some of the feedback, I'm not entirely certain what the question is referring to, is a bit of a kind of people on different ends of this, where some it's you always need to be generating that SBOM, and then some only needed to provide it when there is an actual incident. So if you have any thoughts on that.
Yeah, I actually do have kind of some strong opinions here, but this is obviously the gray area that we continue to operate in when we receive government regulations without a ton of clarity, right? And having worked now very heavily with quite a few of these different government organizations, FDA, CISA, and a few other ones, they're actually intentionally vague in that regard because they would like for both the suppliers themselves, but then even like commercial vendors like ourselves to be able to have enough creative freedom to kind of make some determinations. And so anyway, that background aside, my perspective is this, which is the reason why there's confusion on whether SBOM should be generated generally or only at time of incident is because of embedding that VEX statement. And I think that the more that we move away from thinking about a software bill of material as a point-in-time document and more of this living document that is continuously updated, it'd be very, very clear that a software bill of materials needs to be provided regardless of whether the incident has occurred. And that VEX statement, which can be hosted separately, is the only thing that needs to be updated on a recurring basis anytime new incidents are had. But ultimately, I think that a lot of these organizations need to get off their hands a little bit and just be more prescriptive, frankly. But that's an uphill battle that I think we'll all be fighting on this call for a long time. So.
Got it. Well, with that, we are at time. So, Cortez, thank you again so much for sharing all of your wisdom on SBOMs. Really appreciate it as always. And to everyone who took the time to attend this webinar, ask questions, and spend some of your valuable time. We really appreciate it. Like I mentioned earlier, we'll be following up with emails with additional links. We'll send you a copy of the slide deck and the on-demand recording. Do feel free to follow up, reply to that email, or reach out to us directly with the email addresses on the screen if you have any additional questions. And with that, I think we will close this webinar. So, thank you again, everyone, so much, and have a great rest of your day.
Awesome. Thank you again, Andy. It was a pleasure speaking with you all. Take care, everyone.